We are covering beam bending for the FE civil exam, specifically the Flexure formula and the concept of section modulus. You will find these formulas in the Mechanics of Materials section of the NCEES FE Reference Handbook. The fundamental equation for bending stress is sigma equals mc over I. In this formula, sigma is the flexural stress, m is the internal bending moment at the cross-section, I is the moment of inertia of the cross-sectional area about the neutral axis, and c is the distance from the neutral axis to the outermost fiber of the beam. A common exam problem will give you a simply supported beam with a specific load, ask you to find the maximum bending moment, and then calculate the maximum bending stress. For a symmetrical cross-section like a rectangle, the neutral axis is at the center, and c is simply half the beam's total height. The moment of inertia, I, for a rectangle, is base times height cubed divided by 12. A major trap on the exam is unit management. Your bending moment n will often be calculated in kip-feet, but your cross-sectional properties like I and c will be in inches. Before you plug m into the Flexure formula, you must convert it to kip-inches by multiplying by 12. Failing to do this will give you an answer that is off by a factor of 12, which will almost certainly be one of the incorrect answer choices. To simplify calculations, especially for standard shapes, the handbook introduces the section modulus, S, which is defined as I divided by C. This allows the Flexure formula to be simplified to sigma equals m over S. A larger section modulus means the beam has a greater resistance to bending and will experience less stress for a given moment. This is crucial for design-style questions. For example, the exam might provide an allowable stress for a certain type of steel and ask you to select the lightest W-shaped beam from the tables in the handbook that can carry a given moment. To solve this, you first calculate the required section modulus by rearranging the formula to S required equals the maximum moment m divided by the allowable stress. After calculating S required, you go to the W-shaped tables in the structures section of the handbook and find the lightest beam that provides a section modulus, S, greater than or equal to what you calculated. Remember to look at the SX value for bending about the strong axis. A common mistake is picking the first beam you see with enough capacity instead of the lightest one, which is indicated by the second number in its designation, like a W12 by 50 being lighter than a W12 by 58. For a memorable phrase, think, for bending stress, be a pro, not a con man. Keep your units in inches, from m down to sigma. This reinforces the critical step of converting the moment from feet to inches to ensure your stress calculation is correct. For free practice questions, AI-powered explanations, and more exam prep tools, visit openexamprep.com. That's openexamprep, all one word, .com.